First, let's figure out where we can download the default post processors from Fusion. Go into the manufacturing workspace and open the post library. On the left-hand side of the pop-up, select Fusion Library. You will then scroll down until you find the post processor you want. I ended up using the Mach 3 post processor with a few changes, since I am familiar with that code output. Select Export and save it in a familiar spot on your computer. A trick that I have learned editing post processors from UCCNC here on YouTube is utilizing the Fusion Post Processor extension on Windows Visual Studio Code. In order to download this extension, we must first remove restricted mode. We do this by clicking Manage on the blue banner and then trusting the window. Then on the left-hand side, open the Extensions tab and start typing in Fusion. It should pop up as one of the first choices. Then choose to install the extension. It is already installed in my case, so I do not have the option to install, only uninstall. We are going to open the post processor.cps files we downloaded from Fusion. I will also open the default UCCNC post processor to show you how that post code. While the CPS file is open, in our Explorer tab we will scroll down to CNC Explorer, Cutting, Plasma, and then any of the compensation types will work. This will generate a generic code using that post. If we post a generic code using the UCCNC processor, we can see it generates a code using M10 and M11. These codes are similar to M3, 4, and 5. However, they are better suited for something that needs to turn on and off very fast and have different levels of intensity. This and that there is no probing code is why I chose to stick with the Mach 3 post. On the bottom, we can see a section that says Post Properties. These will be the values we can enter in Fusion during posting. I will change the laser power. Don't forget to file save. You may need to reload the extension by clicking one of the compensation types on the left-hand side. You can see by changing the laser power value, it changed the value after Q to 255, which is 100%. We are also going to see how the Mach 3 post processor would post a generic code. When we try using the extension, we get an error. We can see the error is at line 349. In order to bypass it, and since that line will not be essential, we will just comment it by putting 2 backslashes. We will then edit the post properties to include the z-axis, probing, and some values. That way we can see the change in the code. Once the post properties are set, the code on the right-hand side is the finished product. You can see G92 and G31 code was added. This is code to represent the probing action. First, it will move down 100 units until the probe is touched. Then G92 will zero the z-axis with the offset, -7 in this case. Many people like to add a macro. The macro will group those codes together and reference them by another code. I also like to have different post processors that will add a stop until the cycle start is hit, or a pause after the torch turns off. This can be nice for pieces where there's a high probability of the tip crashing into a cut piece. In this example, we can see M1 was added after M5, which is a stop until cycle start. I also like to add a return to X0 and Y0 at the end because most plasmas will blow air to cool the tip down. Moving the tip back to home can stop some water from being blown out of the water table. My post processors will be available to download from a Google Drive link in the description. But I hope you can utilize this extension to create a custom post processor for your machine. Don't forget to like, comment, and subscribe.